In this section, we're going to use what's called substitution method to solve equations in quadratic form. We've seen plenty of equations that are quadratic, right? So actual quadratic equations would be like, gotta turn my pen on, but would be something like x squared minus 5x plus 4 minus 5x plus 4 equals 0. This is an example of an actual quadratic equation. It's quadratic because it's degree 2, the highest power is 2. And for a quadratic equation like this, we could just factor and solve, x minus 1 times x minus 4 equals 0, set each factor equal to 0, get x equals 1 or x equals 4 as our two solutions, right? So we've seen that a zillion times. What's new in this section is we're going to have something like this, x to the 4th minus 5x squared plus 4 equals 0. So this guy is not quadratic, right? It's not quadratic because it's a degree 4 polynomial, but it's quadratic in form. And this isn't, proper math terminology, but the way that I think of it is if you take the middle variable, which in this case would be x squared, if you take the middle variable, which is x squared, and if you square the middle variable, which would be x squared squared, you get x to the 4th, which is that first variable. So I'm calling these, first variable, middle variable. It's not really, proper math notation, but that's the way that I think of it. If we could take that middle variable and square it, if we get back the first variable, then we have what's called quadratic form. So it's not quadratic, but it's in quadratic form. It's quadratic in form, okay? So it's got that same pattern. The middle variable squared equals that first variable, the higher degree term, okay? So if you look at these steps up here that I wrote in purple, if we notice that we have an equation that potentially is quadratic in form, first I want you guys to check to make sure that that middle variable squared equals your first variable, so that's your first step. Then the second step is we're going to write our what I call the substitution equation. So we're going to use the variable u. If you watch other videos, maybe they use a different variable, but u is pretty common. So we're going to call it u, and u equals whatever that middle variable is. So in our case, in this first example, we have u equals x squared because x squared was that middle variable, right? So u equals x squared. The third step is we're going to rewrite this entire equation that we started with in terms of u. And keep in mind that if u equals x squared, so I can replace x squared with u, right? So that's where this minus 5u comes from. If u equals x squared, if I were to square u, that would be the same thing as squaring x squared, which would give me x to the 4th. So not only does u equal x squared, but u squared equals x to the 4th. So in my original equation where it says x to the 4th minus 5x squared plus 4, I can rewrite that as u squared minus 5u plus 4. U squared is the same thing as x to the 4th, so I can substitute that in. And u is the same thing as x squared, so I can substitute that in. And then we're not going to do this right here. We'll do this in just a minute. But then my next step would be to, the step 4 that I have listed up there, I would factor this equation in u and solve for u. And then after that, step 5, I would replace u with the middle variable and then solve for that original variable, so typically your x. All right, so let's just practice these first 3 steps to get our equation written in terms of u. And I'm going to just erase this stuff just so I have a little more space. Okay, so looking at our second equation down here, my middle variable is x to the 1/3. So first I want to make sure that this equation is quadratic in form. So to check that, I want to make sure that if I square that middle variable, I'll get this first variable. So if I take my middle variable and I square it, that's the same thing as taking x to the 1/3 and squaring it. And remember, I'm going to use the power rule here, which means I'm going to multiply my exponents. 1/3 times 2 equals 2/3. So this would be x to the power 2/3, which is that first variable. Okay, so it is quadratic in form. So that means I can set up my equation. U equals my middle variable. So in this case, U equals x to the 1/3. And by the way, if I take U squared, that would be equal to x to the 1/3 squared, which would give me x to the 2/3. So keeping that in mind, I used to have my equation 3 times x to the 2/3. Now this is rewritten as 3 times u squared, because u squared and x to the 2/3 are the same thing. Then my equation read minus 11 times x to the 1/3, but now this is going to be minus 11 times u, because u and x to the 1/3 are the same thing. And then I just copy down my minus 4 equals 0. Okay. All right, next example. X squared is my middle variable. If I square my middle variable, that's x squared squared, which is x to the 4th. So I do have an equation that's quadratic in form. I'm going to set u equal to whatever the middle variable is. So in this case, I have u equals x squared. And by the way, if I were to square u squared would be x squared squared, which would be x to the 4th. And when I go to rewrite this, I know x to the 4th is the same thing as u squared. Minus 13x squared becomes minus 13u plus 36 equals 0. Let's take a look at our last example. Here my middle variable is x to the 1/5. If I square that middle variable, I'll have x to the 1/5 squared. By the power rule, I'll multiply those exponents together, which gives me 2/5 in my exponent, so x to the 2/5. And that's what I got for my first variable. So I can set u equal to my middle variable, which is x to the 1/5. And by the way, if I square u, which I basically did over here, right? U squared would be x to the 1/5 squared. That's going to give me x to the 2/5. So u equals x to the 1/5, but it's also a fact that u squared equals x to the 2/5. So where I had x to the 2/5 before, that's now u squared, plus x to the 1/5 is now plus u minus 6 equals 0. All right, so let's keep going with that first example, that very first equation that we saw, x to the 4th minus 5x squared plus 4 equals 0. So we have this equation. We recognize that it's quadratic in form because the middle variable squared equals my first variable. Remember, I already set up u equals my middle variable x squared, and then I rewrote this equation in terms of u squared minus 5u plus 4 equals 0. So that's where we left off in the table, right? So we left off there in the table. Okay, so after this, my next step is to factor this equation on the left-hand side, factor that expression on the left. So factoring that trinomial, I get u minus 4 times u minus 1 equals 0. I set each factor equal to 0, solve and get u equals 4 and u equals 1. But I'm not finished. So this is a lot of times where students mistakenly stop. They get the 4 and the 1, and they're like, I'm so smart, I got the right answer. And you can still be smart, but you didn't get the right answer yet. So the next step is we need to replace u with x squared, and that's based on this guy, right? So I got that u equals 4. But remember that u equals x squared. So now I'm focusing on solving x squared equals 4. Okay, my original equation didn't have u's in it. It had x's, so I need to solve for x. So I have x squared equals 4. I take the square root of both sides, remembering my square root property, plus or minus. So this gives me two solutions, x equals -2 and x equals +2. I also have u equals 1, so if u equals 1, and I know that u equals x squared, now I'm focused on solving this equation, right? X squared equals 1. Take the square root of both sides, remembering my square root property, so x equals plus or minus 1. This gives me these two solutions. Okay. So, looking at number 10, it says solve using substitution. X to the 4th minus 13x squared plus 36 equals 0. First, I want to make sure it's quadratic in form. I'm going to take my middle variable, square it, which is x squared squared, which gives me x to the 4th. So this confirms that I have an equation that's quadratic in form. So that allows me to write this equation, u equals x squared. So remember, I'm taking u and setting it equal to whatever my middle variable was. So in this case, u equals x squared. And by the way, if u equals x squared, then u squared would equal x to the 4th, right? So now I'm going to rewrite this equation in terms of u. I'm going to replace it with u squared minus 13u plus 36 equals 0. I'm going to factor. And let's see, we have u minus 4 times u minus 9 equals 0. Set each of these factors equal to 0, so if u minus 4 equals 0, I get u equals 4, and if u minus 9 equals 0, I would get u equals 9. But I have to go in and replace u with x squared. So where it says u equals 4, I'm going to rewrite that as x squared equals 4. And where it says u equals 9, I'm going to rewrite that as x squared equals 9. So remember, we're trying to solve for x, not for u. To solve x squared equals 4, I'm going to take the square root of both sides with my plus or minus. This gives me x equals plus or minus 2, so there are two solutions. And then solving x squared equals 9, take the square root of both sides, plus or minus, x equals plus or minus 3. So those are my two solutions. And again, remember, I had a degree 4 polynomial. I have 1, 2, 3, 4 solutions. That won't always be the case. Sometimes you have repeated solutions, but that's something to check for. If you have a degree 4 polynomial, pretty common to have the full 4 solutions. Okay, so that's not unexpected. All right, now let's take a look at number 11. We want to solve this using substitution. I see that my middle variable is x to the 1/5. So if I take my middle variable and square it, that's x to the 1/5 squared, which by the power rule gives me x to the 2/5, which was my first variable. Okay, so this tells me that I have an equation that's quadratic in form. So that's good news. That means I can use this substitution process and move forward. All right, and one quick thing I want to point out before I move forward. When I set up my u equation, I'm going to set u equal to the middle variable. I see this all the time on test day. People are like, okay, great, so u equals 2/5 or u equals 1/5 or something like that. And then the x just goes bye-bye. So please be really careful not to do that. Don't just drop that x. The x is pretty important, actually. It's our variable we're solving for. So when it says u equals the middle variable, remember that my middle variable was x to the 1/5. So u equals x to the 1/5 is that substitution equation. And if I squared u, I would have x to the 1/5 squared, which would be x to the 2/5. Okay. All right, so I'm going to rewrite this equation in terms of u, where it says x to the 2/5, that's now u squared, plus x to the 1/5 is now plus u, and then minus 6 gives me 0. I'm going to factor u plus 3 times u minus 2 equals 0. U plus 3 equals 0 means u equals -3. U minus 2 equals 0 means u equals 2. But then remember that I need to go back in and replace u with x to the 1/5. So where it says u equals -3, this is actually x to the 1/5 equals -3. And u equals 2 is x to the 1/5 equals 2. All right, so solving x to the 1/5 equals -3. Remember, I have a rational exponent. I can raise this to the reciprocal power. The reciprocal of 1/5 is 5. And I'm going to raise -3 to the 5th power as well. Now, if you're at all in doubt, use your calculator. That's what it's there for. X equals -3 to the power 5. I'm going to put that in parentheses, -3. Use my caret symbol to the power 5. And that gives me -243. Notice that -243 is not a -15. Those are different numbers, right? All the time on test day, I get -15 there. -3 times 5 equals -15. That's a fun fact. That has nothing to do with number 11 that we're trying to solve, okay? So make sure you're taking -3 and raising it to the exponent 5. And same thing over here. X to the 1/5 equals 2. Going to raise both sides to the power of 5, that reciprocal power, and get x equals 32. Notice that 32 is not 10.